Alrighty guys, we have made it to the Magnetism notes part 3. These notes specifically are going to focus on the right hand curl rule. And we're going to talk about what that is right now. So the right hand curl rule is a rule in which it shows us the direction of a B field, and remember B field just stands for magnetic field, in a current carrying wire. So let's talk about how that works. Well, in order for this to work, we need to take our right hand, point our right thumb in the direction of the current. Remember, current can be abbreviated with the letter I, and we need to wrap our fingers around the wire. The B field is going to travel towards the ends of our fingers. So again, what this rule does is that it allows us to take the knowledge that we know. We know that currents that carry wires generate magnetic fields. And now we can figure out what direction those magnetic fields point, or what direction the current is flowing in a wire using this simple trick. If we look at our diagram over here, our thumb points in the direction of the current, so our thumb points up here, meaning that the magnetic field is going to point counterclockwise around this wire. We look here, it's the same diagram, just more vertical. Thumb points up, magnetic field counterclockwise around the wire. So we're going to say that we use specific symbols to show the direction of that B field in a current carrying wire. And we define those as either out of our surface / up towards the ceiling, because our wires are most likely laying flat on a surface. So if we said that the wire was flat on a table, we could define it as pointing up out of that surface or towards the ceiling for the magnetic field. In order to do that, we're going to use the symbol, it looks like an O or a circle. Next, if our magnetic field is pointing into the surface or down towards the floor, we're going to use an X. And we could think of an X as just like X marks the spot, right? If we're going into something or down towards something, we want an X. And if we're coming out of the surface, we want an O. So let's take a look at the two examples below. We want to indicate the direction of the B field in these wires. So on the left-hand side over here, we can see that we have a current that is pointed down. So I'm going to take my right thumb, I'm going to point it down, and then I'm going to pretend that I have a wire in between my palm and my fingers. Well, what do I notice? I notice that my thumb is pointed down, and my fingers on the left-hand side of that wire are going into my computer screen. So because they're going into my computer screen, I should have an X there on the left-hand side. And on the right-hand side, they're coming out of the computer screen. So I should have an O on the right-hand side. So O on the right-hand side, X on the left-hand side. Perfect. And just like we said, it's because my fingers go in on this side. They wrap around and come out on this side. Next, let's take a look at number 2. So for number 2, I point my thumb over to the right, and again I'm pretending that there's a wire in between my palm and my fingers. So I notice that my fingers are pointed towards me this time. So if I'm pretending that there is a wire between my palm and my fingers, under the wire I'm going into the computer screen, and over the wire I'm coming out of the computer screen. So I should have an X down here and an O up here. And there we go. So let's take a look at another example here, and this is a circuit. So if you remember, this is kind of a schematic diagram, and it's a circuit without any resistors, so a shorted circuit. But essentially we have a battery here, and we know that current flows from the positive end of the battery down to the negative end. And these are just wires. So at these different wires, we want to figure out where the magnetic field is pointed throughout this circuit. So first thing to identify is that the circuit over here has current that's pointed to the right. So when the current makes it to this point, it's pointed down. So let's take our thumb, point it down. We notice that our fingers are going into the computer screen on the left-hand side, and on the right-hand side, they're coming out. So inside here, I should have an X, and over here, I should have a O or a circle. So there's my O on the right-hand side, and there's my X on the inside. Next, my current points down, and then over here, my current is now pointing to the left. So I do the same thing, point my thumb to the left, always the right thumb, over the wire, I notice that it's going into the computer screen, and under the wire, I notice it's coming out of the computer screen. So this should be an X over here, and this should be an O right here. Here we go, 2 for 2. Now let's take a look at our last one. So again, the current's pointed this way. Now the current points up because the current's just flowing around the circuit. So I point my thumb up. I notice that on the right-hand side of the wire, or inside the circuit, my fingers are going into it. And I notice on the left-hand side of the wire, meaning over here, that my fingers are coming out of the computer screen. Therefore, this should be an O, and this should be an X. And there we go. Perfect. We also probably just could have realized that all of these boxes are inside the circuit. And because the current is flowing around this circuit, it would mean that the magnetic field needs to be pointed in the same direction around the circuit. Therefore, whenever we are inside, the magnetic field should be pointed into, and into. And whenever we are outside, the magnetic field is pointed out of, and out of. I highly recommend that if you guys are struggling with this, just make sure you're taking your thumb, pointing it in the direction of the current. If it helps, maybe take a pen or pencil and put it in between your fingers and your palm, pretend it's the wire, and then look at where your fingers are in regards to that pen or pencil. So on the left-hand side of the pen or pencil, which would be over here, I notice that my fingers are going in, and on the right-hand side, I notice that my fingers are coming out.